We've seen a few videos on the chain rule. Here is the last one in that sequence of videos, and it's mainly here just to kind of prime you for related rate problems, which are classic calculus problems that a lot of students have a hard time with, and it's because they don't understand that it's just application of the chain rule using symbols instead of functions that we can actually see. So this is meant to just draw your attention to that fact, kind of almost like a bonus little lesson, because it really has to do with related rates, but I wanted to throw this in there for my students at least. So I have here that the radius and surface area of a sphere are related by an equation. So you could say that the surface area is a function of the radius. That's what that equation means. But then it says that the radius is changing over time. So that must mean the radius is a function of time. So you've got the sphere and the radius is growing, which means that the surface area is growing, and the radius is a function of time. I think that's worth writing. I'm going to say i.e. the radius is a function of time. And s equals 4 pi r squared means that s is a function of r. So maybe let's write this. R equals, now I don't know exactly how the radius is changing. I mean, if it's changing, at 4 meters per second, then I would write, r equals 4t. If it was changing at a different rate, I'd have to write the equation down. I don't know the equation, so I have to say something like r equals f of t. It's just some function of time. Some expression that has t in it, maybe. We're interested in two rates of change. S is changing with respect to r. We want to know what that rate of change is. So in calculus notation, we want to know what is ds dr. Now that's easy. If you look up at the relationship between s and r, s equals 4 pi r squared, and the only variable in that expression is r. Pi is not a variable. So you just use the power rule, bring the 2 down, and you get 8 pi r to the 1. Now here is the kind of the whole reason I'm doing this video. S is changing with respect to time. What's that rate of change? Well, since s is a function of r, s is a function of r, and r is a function of time, if we want how s is changing with respect to time, we want ds dt. And according to the chain rule, that's going to be ds dr times dr dt, which is equal to ds dr we know is 8 pi r. And dr dt is, we don't have an actual function for it, so we just have to use the notation dr dt. All right, so I'll just end here, just as this is kind of a primer for related rates, but it's very important that you pay attention to what you're taking the derivative with respect to. If you're taking the derivative of s with respect to r, its most immediate input variable, then you just get 8 pi r. But if you're trying to find the rate of change of s with respect to time, which is sort of, 2 variables away, right? It's s and t aren't directly related in terms of how this problem is expressed, then you'll need to use this chain rule, and your final answer is going to look like that. And we're going to be comfortable leaving that dr dt there, because in an applied problem you'll end up being given what that value is. So again, just a final video on the chain rule, which is meant to prime you for related rates.